We've been doing math for many, many years now, all of us. And in doing that, we have gotten used to certain notations and facts about real numbers and integers that we just use without thinking. And some of these we will continue to use when we are talking about groups for very good reasons. So let's talk about some of these. So we have certain notations and facts that are true for multiplicative groups. So as a definition, when you multiply a group element together many times, we use exponent notation. So g to the n we are going to use for g times g times g times g when we multiply g together n times. And we also use, when we have g to the 0, what do we get? If you take 2 to the 0, that's defined as 1 when we are talking about real numbers. What is 1 for a multiplicative group? That is the identity. So in general, g to the 0 is going to denote our identity. We already said that we are using the to the minus 1 notation to denote the inverse. So g to the minus 1 denotes the inverse. Inverse of g. And so we can combine those two things together with the to the n notation. So g to the minus n is going to also be g inverse raised to the nth power. So that is g inverse multiplied together n times. A few other facts. G to the m plus n is equal to g to the m times g to the n. So rules of exponents carry over. G to the m raised to the n is going to be g to the m times n. But a word of caution, that has to do with the fact that groups don't have to be commutative. So in general, it is not true that a b to the n is equal to the a to the n b to the n. That is because that is only true if a group is commutative, and so there's a big fat not equal right here. So don't use that in general unless you know that your group is commutative, and that we'll have to prove. A few more facts now for additive groups. So n times g is going to denote g plus g plus g plus g n times. And I didn't say it yet, but n is just some positive integer. And the positive integers are denoted by that double barred n, so a positive integer. Okay, what else do we have? We have, when we have 0g, that is the identity. And what about inverses, the notation for the inverse? Well, that is in an additive group minus g. So minus g denotes the inverse of g. And so if we have minus n g, that is the same as n times minus g. And that is minus g plus minus g. So just n copies of the inverse. Okay, a few facts over here. If you have m plus n copies of g, that is the same as mg plus ng. And if you have n times mg, that is equal to nm times g. And in both of those facts, m and n can be any integers. So we are talking about having a certain number of copies of a group element that is just added to itself over and over and over again. We'll be using these notations throughout, so you'll get more comfortable